Covalent bonds. Another type of strong chemical bond deck two or more atoms is a covalent bond. These bonds are formed when an electron is decoupled between two elements and are the strongest and most common form of chemical bonds in living organisms. Covalent bonds are formed between deck elements that make up the biological molecules in our cells. Covalent bonds, unlike ionic bonds, are usually insoluble in water. Which is stronger, the ionic bond or the covalent bond? Interestingly, chemists and biologists measure the bond strength in different ways. Chemists measure the absolute strength, theoretical strength, of a bond, while biologists are more concerned with how bonds behave in a biological system. In biological systems, bonds are usually in the form of water dissolution, aquatic. In water, ionic bonds break down more easily than covalent bonds, which is why biologists say that ionic bonds are weaker than covalent bonds. If you look at a chemistry textbook, you will see exactly the opposite. Ionic bonds have a higher dissociation energy, and therefore they are stronger than covalent bonds. This is a great example of how the same information can lead to different answers from the point of view that you're studying. Hydrogen and oxygen atoms, which combine to form water molecules, are connected to each other by covalent bonds. The electron in the hydrogen atom decouples its time between the outer layer of the hydrogen atom and the incomplete outer layer of the oxygen atom. In order to completely fill the outer layer of an oxygen atom, 2 electrons from 2 hydrogen atoms are needed, due to which the alkene H2O is 2. Electrons are shared between atoms, their time is decoupled to fill the outer layer of each of them. This is the sharing status. For all the atoms involved, it is a lower energy state compared to their state, in which they stand without filling the outer layers. Apolar covalent bonds. There are 2 types of covalent bonds, polar and apolar. Apolar covalent bonds are formed either between 2 atoms of the same element or between different elements that decouple electrons equally. For example, an oxygen atom can be connected to another oxygen atom to fill its outer layers. This partnership is decoupled because electrons are evenly distributed between each oxygen atom. 2 covalent bonds are formed between 2 oxygen atoms because oxygen needs 2 electrons that are shared to fill its outermost layer. Nitrogen atoms will form 3 covalent bonds, also called triple covalent, between 2 nitrogen atoms, since each nitrogen atom needs 3 electrons to fill its outermost december.